let's talk about the system design core concepts. So till now, what we discuss in the system design part 1 is the basics, and now we are going to talk, you can say, system design core concepts. So core concept means ki as a system designer, while designing system, these key concept we should aware and we should be clear. First, about what is the system you are going to design. First, you have to define the architectures, and this architecture can contain some components. You have to define all the components: component 1, component 2, component 3, component 4, and this is your system. Okay, and this system's architecture, and might be they are how they are going to talk to each other, maybe different, maybe third party vendor. So what are the interaction between your within the components, component 1, component 2, component 3, maybe some different architecture, different systems, how these are going to talk to them, what are the channel, what are the protocol, what are the communication mechanisms we are going to deal. And last, we got any software we are going to build. Sometime, mostly our software required to the data management. Means customers provide some kind of input data, and you as a software are going to persist somewhere in the file system, somewhere in the database, somewhere in the different location, some files. So as a software designer, our responsibility, be carefully we designs our data, because data is also very important concept while system design. Okay, because finally all your architectures, all your component, all your interactions work on your data, and how you are taking input data, how you are responding data, how frequently you are getting data, how fast you are responding data, how you are storing all this data in the secure place, how maintain the consistency, accuracy, lots of basic system concepts we have to maintain our data management. What are the flow of data, what the number of different viewpoint of the data, what kind of different customers, what kind of percentage of data they can view, what are the secure information which user or customer are authorized to see, which are not authorized to see. Very big, you can say, topic about the data part, the informations which our system is going to take from the customers and storing some secure places. So these are the 4 key pointers for any system designs. Okay, so your system must address these points while designing your system. First, you define your architecture. Our architectures is the base, so that our architecture ensure that all our NFR can be met, like scalability, availability, fault tolerant, caching, component integration, communications. In future, in flexible, one architecture, one component communicate with another components. All other things are defined, support by my architectures. Okay, and then this is the basic components, user requirement, different functions. Finally, we implemented the different services, different microservices, different modules. Maybe some components related to the my application, some component related to the third party, some different vendors, right? And between those, how my application, my architectures are interact to make data communications, how it's sending messages, and finally how our systems are storing, retrieving, and securing my data. Because lots of different kind of data, different uses of data. So depend upon the uses of data, depend upon the types of data, depend upon the nature of data, we as a software engineering team ensure that we are capturing all kind of data management requirement, and be ensure that you are storing, transforming, displaying data as secure, as permissible, because customers are relying on my system. So our responsibility, we have to deliver systems, we have to deliver our software that can meet the customer data security as well as. So later parts, later times, surely we are going to talk more about the architecture, component designs, interactions, and data management. But as of now, today I am going to just touch brief basics of these 4 points, okay, so that you can get basic sense. What are the, you can say these are the very big picture of your system. Whatever the one software component you are going to define, so this software component can be, as a software engineer, we can view as a architectural point of view, we can view as a component point of view, we can view as a interaction point of view, and we can view as a data point of view. And while designing this system, we have to consider these different points. You cannot miss anything, you cannot miss this, you cannot miss this, you cannot. Don't just focus what the customer requirement, how I'm going to write the code. No, coding implementation is the last part. Until you are not design system be sequentially, be accurately, might be bigger problem in future. So whatever the system design concepts we are going to discuss here, it's for our software. Once you deliver, after that, the number of year you are going to serve, how they behave, those number of year, 5 year, 10 year, 20 year long, after the deliver the software, if your system architecture, data management, interactions are well defined, well thoughts implemented, your systems are more flexible and maintainable, which generate revenue for the customer. If you are not considering these points while implementing customer requirements, customer can lose our trust after maybe 1 year, 2 year. If again they are going to ask, hey, this is a problem, they are not securing data, your interaction is not happened with third party, your application is not support pluggable, your architecture is not extendable, your components are not able to talk to these. So lots of challenges come, and later for decide, let's say you're going to build the new application, new system. That customer will lose lots of revenue. Okay, so these additional steps like system design concept, we are going to implement along for the specific customer requirement. Why? Because these are give customer satisfaction, customer confidence. Hey, these things were, while going to talk to the customer, we are going to ensure that the software we are delivering, this will meet your expectation in the coming years on years. And these points also ensuring getting confidence of customers. Hey, we are securing your data, we are ensuring your data, your application is more flexible. So when customer listen this basic concepts, they are really believe our software. Whenever customer start believing my softwares, in Suriman, our software perform more better, more expected as expected. If customer is initially not, you cannot get a customer confidence, highly chance our software is not going to success on the after a couple of years. So whatever they're delivering, please get the customer confidence. These system designs, whenever you talk against the customer with these concepts, customers are believing you. And this is the key success of system design. Lots of extra things we are going just beyond this implementing very small customer requirement. Let's simple use case. Hey, you can design hotel managements or room ticketing systems, maybe lots of use cases. Very simple requirement. You write the code and just deliver a small software, small code. User can use this, but they are not more scalable. They are not more maintainable. They are not more fault tolerant. Lots of things by default a simple code cannot manage. Due to that, this complete system design is one of the key concept in this software industries. This design concept always be applied for every revenue generating software. You are building software for just knowledge purpose, for college purpose, for student purpose. Okay, you cannot consider all these system design concepts. No problem. Just for a learning purpose, just for a completing some particular course, degree, certificate, it's okay. But whenever you are going to talk any enterprise application, any software that are going to generate revenue for our customer, so these points are really help us to get the customer confidence. Okay, so we cannot skip these points. Many initial software engineers thinking, while lots of things we are talking, I know this is a customer requirement, I know the programming language, I can write the code, and this is the code, let's give to the customer. Initial thoughts come, but at the time of junior level engineer, senior level engineer, they are not thinking how this code sustain in 5 year, 10 year, 20 year, is handle lots of circumstances, lots of situation, they can meet, they can survive. The system designs enforce as a system designer to us, hey, let's think on these points before going to write the code, before going to implement the code. Code implemented is the last part, implementing, testing and delivering. But before that, you have to think all your architecture, component, interactions and data pointers. Okay, so I'm not going to talk more details about this because these all four are independent. Lots of deep discussion required, and lots of each four, lots of designs principle, pattern, approaches, framework, technology available to deal with each four. For managing data, lots of technology, framework, methodology, algorithms available, and lots of database available, different kind of database available, different kind of transactional management, distributed transaction, lots of things we are going to talk details. Actually, these are the very high level point or concept. We as a software designer, we have to, system designer, our responsibility, we have to consider this point. Without considering this point, we cannot meet the success of my delivered software. So let's talk basic. What is the system architecture? Because this term architecture, we can listen from different point of view. if you talk about the architecture terms, is not only for the software industry. We not generated this architecture words. Architectures are before maybe IT industry started. Still, people's engineers are using the terms architecture while maybe building your house, while we're building your factory, while we're building some components. They are using architectures. We are building our buildings, house, offices. We are defining our architectures. So architecture are the basic foundation. On the top of that, you are building complete your house, complete your factory, complete your business entity. So architectures are very, very basics, and you can say very, very important key concept of any point of view where you are going to deliver the things. We talk about the manufacturing, or you talk about the construction industries. If you talk about the different in any industries where they are using the terms architecture. Architectural are basic blueprint or foundations. On the top of this architecture, complete building, complete house you are going to construct. Same length, lambai, width, everything you can define in the architecture, so that your outcome of the architecture is the actual business, actual building, actual factory, actual company. Similarly, we are using these terms about the architecture in our software industries. So these are very high level structures of a software system. And these are again including the same details, because these systems you are defined to meet the customer requirement. What are the customer requirement of the different components? And once you define the different component may be modules, component may be services, component may be microservices, component different independent deployable components or services. So how they are interact to each other, what kind of API, what kind of protocol, what kind of buffering tools, what kind of security layer, how can I ensure TLS, lots of things you are ensuring how they are communicate, maybe within a system or maybe outside of the system. Similarly, the relationship, many you are defining multiple component or modular modules. Might be one module have some relationship another module, one module may be dependent to another modules. What kind of a dependency, one kind of a relationship. And relationship can be maybe unidirectional, bidirectional, completely, incompletely, fully, partially. Lots of things we are going to talk more. So whenever we are defining our software architectures, we have to think again all my customer components and interaction between them and the relationship between. So whatever you can say are defining my architectures. Hey, this is the component 1, component 2, component maybe 3, component 4, maybe database component, maybe some third-party library, maybe some file system. Lots of component here we're talking. We are storing some data in a file system, some database, some search engine. That these are different components, different functions. How whenever you talking complete system here, now this is the complete system. So hey, my system can how interact with the UI, how interact to the customer. Now what kind of relationship between this component, how they are interact to, how to publish the data in the file system or database, in email notification service. Lots of things you can say. So here architecture refer complete building blocks are the components here. So all the component maybe modules, maybe services, maybe library, maybe third-party components, all are that, and the interaction. So system architecture consider all are your functional, non-functional modules or functions, or you can say area, or you can say sub area. We have to consider everything as a components. Whatever the function, maybe good example like you are going to add the maybe add the product in the system. So the product is the one, types of product is the one view, product which are quantity, quality, and rating point of view, maybe the which kind of locations, different location, different customer, different what kind of level of customer we have. So you can think every detailed perspectives, and accordingly you can build different component. And what one component can be become a library, one component can become a software itself subsystem, one component can become a microservice, one component can become a simple one modules, one component can become simple subsystems. So you while designing your software architecture, we have to consider all possible areas where data are going to the flow, applications are going to the flow, and you can partially divide as possible in the different subsystems, different component. And later part, you have to think how our application workflow while our customer working with this component, how they are interacting one directional, unidirectional, multi-directional, what the protocol, what the channel, is the secure channel, is the non-secure channel, is the TCP, UDP, TLS, what kind of protocols they are going, application layer protocol, transport layer protocol, physical layer protocols, each and everything we have to consider. Even I'm talking this interaction, you don't need to explore each and everything. For interactions, lots of inbuilt third-party technology frameworks available. Just we have to explore them and we have to reuse them. Similarly, relationship also kind of relationship, maybe inheritance, maybe component, maybe association, maybe dependency inversion, lots of kind of a component. Is a relationship, has a relationship, strong relationship, weak relationship, inheritance, composition, lots of things. While the different component, according to the natures of component, we have to defining the relationship. So these combines make a high level structures, and that structure you can say help us to build actual your system. So these are the very key you can say basics related to the architecture. Architecture is still itself one big subject, and even we cannot complete, but our objective, let's understand very high level, very basics, at least someone talking about architecture, we as an engineer make sense, hey, something related to here talking basic building blocks are high level structures. On the top of that architecture completes software build. Okay. So let's talk next like here architecture, next components. So already we discussed components, that means that more related to the your customers requirements. Okay, customer requirement, and customer requirement might be related to the some another use cases. Maybe one customer requirement interact to the rating system, might be one customer requirement may interact to the payment system, might be one customer requirement may interact to the internal local server system. So while understanding the customer requirement, we have to deep dives and understand the functions, the use case where you can say self explainable, self testable. You need to code that from a specific function. For each independent specific function, you have to separate out the separate model. Okay, and similarly, the components which you are talking, specific functionality are to the other. For each and every specific functionality is one use case, you make one maybe services, and similarly kind of a very small independent services that communicate to each other can be deployed separately, that we have to consider. So here a component is the very bigger terminology. Here you talk more like independent, you can build independent library, utility library, maybe services, maybe or REST services, SOA services, SOAP oriented services. Maybe similarly you can build one depend upon the independent deployable you can say component, yeah, microservices. So here components can refer to module, can refer to the services, can refer to the microservices, and or maybe any other existing applications. Okay, can be one component where my one modules can communicate with other components. Okay. So component means specific function, a specific requirement that can serve. So objectives of the component in the software architecture is that you are going to bifurcate, break down your customer requirement as lower as possible, so that one independent function requirement can be written independently, can be tested, can be deployable possible. It can be very small independent services, then become microservices. We can deploy the separate instances. Maybe services can be bigger something, models maybe different. So depend upon the level of requirement, you just bifurcate, just break down and understand the requirement and define your modules, define your services, define your microservices. And last part of your architecture about the interaction. Interactions already talks. Interactions also we have defined, hey, this is the one microservice one. We have built another microservice. We have built another microservice. Okay, multiple microservices you have to build. So now this microservice independently receive the request and responding. This microservice independently receive request and responding. Receive request and responding. They are working very fine. But sometimes the customer requests come and they require some data from this microservice, or they require data from this microservice, or they require data from here and then again come back. So lots of permutation combinations in the real application happen. So those scenarios, how our software, our microservice, our modules are communicate. So generally we talk about the application programming interface, how components are defined and interacts. And whenever any communication interaction happen, the next point talk about the protocols, rules that govern how communication happens. So whenever you going to one microservice called to another microservice and they are exchanging data. So while exchanging data, might be this microservice built on the different technology, this microservice built on the different technology, how they talk to each other, what are the grammar, what are the vocabulary. So this is known as a protocol. Protocol is the one way where one party, one software component, one program can send or can exchange data in a particular rules and regulation. So lots of protocols here we have a where the messages are exchanged. Maybe application layer protocol, session layer protocol, presentation layer protocol, network layer protocol, IP layer protocol, physical layer protocols. Lots of protocol. They are ensuring that how one microservice are going to send or exchange or data between that. What would be the data format? What the language they support? What data they send? What the responding they are sending? How they are talk to each other? They can understand. Maybe this is written in C++. This is written in Java is a language. How they are talk to each other? So these are all the things we have to talk while discussing the protocols. Even here again I'm trying to say, so here protocols means as a designer, software engineer, we are not going to understand the complete protocol details history. No, for your microservices, for module, for services, how they are communicating, what kind of protocol, already we have inbuilt solution available. Our application framework, Spring framework, Quarkus frameworks, and all are there already provided the solution for us. Just we have to choose, hey, this is my application framework, this is the protocol, maybe HTTP protocol, maybe FTP protocol, maybe HTTPS protocol, maybe TLS enable, maybe SSL enable, all are the here option available. Just we can use them. We are not going to deep dives, explore everything from the scratch. No, we are responsible to just figure out, hey, for such kind of environment, which protocol technology available, framework available, we have to just use them. So these interactions are very, very important in our software, because sometimes our application can interact to the different kind of application. Maybe I discuss my applications, or maybe some loan processing path, maybe credit card, something. So before processing loans, they are going to the check, hey, what is the customer rating, is eligible, not eligible, might be completely one system talk to another system, completely different environment, different technology, everything, maybe mainframe, something different way written. So is my application in such a way designed that can interact to the some legacy application, maybe some different kind of agency services. Maybe talk about the authentication, might be in our country, say, hey, I want to maybe Aadhaar based authentication or PAN based authentication authorizations. Is it valid user validity? How can you ensure that this is valid user, particular registration, not registration? So many cases our application can interact, can communicate, maybe some completely independent kind of services. Maybe talk to the services, maybe talk to the application, maybe talk to the complete different kind of systems. So while designing system, we as an engineer, our responsibility, we have to also ensure that our applications are capable to interact with the different kind of application program. So with the API means application program interface, different kind of interface communication can be, and which channel, which protocol we are going to follow. So you can say these are the very basics about this component, about these interactions. And last not least, but this is also very important parts about the data management. The data, finally your systems are going to reading data, writing data, storing data, maybe less amount of data, high amount of data, very high amount of data, read only data, maybe write only data, maybe sometimes write both data, read only data, write only data, maybe both kind of data, frequency of data, how much fast we are providing the read is so fast, or write is so fast, or both. The nature of data, we have to use the different kind of databases, different types of database nowadays available. So for this, if you talk database, not just one kind of relational database, we have a different kind of SQL database, NoSQL database, NoSQL also a different kind of category. Maybe you can show the document oriented database, maybe columnar oriented database, maybe graph oriented database. Maybe sometime you want to store some movie, video, files, images, might be not used for proper database. Maybe you are going to use a different kind of a file system, maybe Amazon S3, maybe CDN, different kind of technology available. Just we have to choose for the data storage. Okay, and data storage in a nowadays in a database technology, we are available different kind of database, huge number of database available, not just we know MySQL, Postgres or ABCD, like maybe for the SQL lots of SQL database, means RDBMS database, similarly NoSQL, multiple database available. So depend upon our use cases, depend upon our situation, might be one application required to use the multiple database, depend upon the somewhere I want to so frequently search and read something, the different database we are going to use, because they provide the different capability to read and search data. Okay, sometime our application want to mostly write the messages, write the blog, write the something, so might be going to the different database. Okay, so depend upon the nature of usage, nature of application use case, data flow sequence, different component, different microservices, different database they can use. Maybe one microservice with the MySQL, one maybe Cassandra, one maybe MongoDB, one maybe S3, one maybe CDN. Okay, so might be designing your system depend upon the nature of data. We as a system designer, we are supposed to talk about the which kind of database we have to serve. Even nature of data is very important. Also the size of data, how much data we are going to store, what the frequency, how many number of days we have to maintain, how many number of year we have to maintain those data, maybe time series data, non-time series data. So depend upon the nature of data, we are going to talk about your data models and data storage. Data models means your data is structured data, what are the relational data, non-relational database, data storage, and similarly data retrieval, maybe searching, maybe finding, maybe different kind of fuzzy search, non-fuzzy search, simple search. A searching come from the simple storage data or huge volume of data, depend upon the your application uses. So depend upon the application usage, data management is a very key concept. And even we not just think about only one kind of data. Hey, RDBMS, maybe you can talk about the RDBMS, you can talk about the non-RDBMS NoSQL. Even NoSQL bifurcation have a multiple kind of database available according to the different use cases. And similarly we have a search capability, we have lots of different open source software available, such like Elasticsearch, like Open Search, so solar systems, different systems we have. So while system designing, nature of data, we have to propose customers, hey, these kinds of model we have, and accordingly we are going to select here the MongoDB, MySQL DB, Cassandra DB, whatever DB we have. I'm going to use Elasticsearch, I'm going to ELK, I'm going to Open Search, and lots of software tools available. So as a system designer, we have to know lots of technology framework is already available in the data management section. Similarly for interaction, similarly for architecture, similarly for relationship. So whatever the things we talk as a while the system designing, maybe you talk about the architectures, maybe you talk about the component, maybe you talk about the interaction, maybe you talk about the data management. So for each section of system design, you have to know lots of architectural pattern available to implement your software. Maybe your MVC pattern, maybe cloud native, maybe microservice enable, lots of architectural pattern available nowadays. Cloud native, micronet, PFF, lots of. So we as a software engineer, our responsibility, we at least know this is the my event driven architecture, or maybe sequential architecture, maybe you can say layer architectures, maybe event driven architecture, depend upon our application. So we at least know as a these kind of different architectural pattern available, maybe different kind of style, different kind of patterns for architectural support. We are not going to invent everything, but we should know. Similarly for the component, what are the way to break down the component, what kind of a component should be, how, when we can decide that going to the modules, services, microservices. Similarly for interactions, we are going to maybe REST API call, HTTP API call, event based call, different kind of interaction software available. Okay, event based, HTTP based, synchronous communication, asynchronous communication, HTTP based, HTTPS based, FTP based, non FTP based, lots of protocols. So we have to just know these are the software tools, technology already available. Similarly for database, lots of database designs available. SQL database, non-SQL database, non-SQL maybe high read, high write. Usually I want to frequently search kind of options. The nature of data you can decide go to the databases, maybe relational, maybe non-relational, maybe combined, maybe multiple database. In some applications, some use cases we are going to use. So these are the key, you can say, principle about any system designs. You system designs, maybe you are going to do. So please consider your architectures, consider your components, consider your interaction, consider your data management. Once you consider all these points, then you can design your system. Not just take only architectural point of view. No, one point of view it's okay, but not you not design complete system. Only decide architectural point of view. Don't talk about the component, don't talk about the interaction, don't talk about the database. Your design is not complete. So please make a habit to look your system broadly, very high level, so that you can look every aspect of your applications. And once you decided complete view, all the function, all the area of your system, then each and every component we are going to the deep dive about the architecture, about the component, about the interaction, and about the database. And again further deep dive, that is come under your implementation. So one is the high level design and documentation, then low level design and documentation, then implementation, then coding, then testing, then releasing. Okay, so here these are the basic things, but this is not the only. Apart from that, once your software build, you have to think how to the build, how to the deliver, how to the deploy, what the frequency. See, automatic nowadays continuous building, continuous deployment process. So we should know continuous deployment process, continuous build process, and not the only things. As a designing of system, you also we have to consider where my application is going to deploy, which infrastructure they are going to deploy, which kind of environment you are choosing for deployment. Maybe for that, maybe scaling, capable, high availability, HA. For that, we have to also talk about the deployment strategy. So in the system design, not this 4 component. Beyond that, like a CI/CD pipeline, like your orchestration, like talk about the Kubernetes, talk about the Docker, and similarly we have to also consider talk about the deployment model, which kind of a cloud you are going to the cloud enable, native cloud or on premises. Lots of things we have to consider to meet the success of your systems. So surely 1 or 2 lectures is surely not sufficient to complete this topic. I am going to talk more and more small pieces about this system design surely, but these nowadays our today objective, at least I can give you the very high level point of view where we have to consider the system design. Okay, so again repeat, while system designing we have to talk about the architecture, about your component, means module, services, microservices, your communications, synchronous communication, asynchronous communication, secure communication, non-secure communications, and about the data management. And apart from that, you have to talk how frequently our application is going to the build and application going to the deployed, and where they are going to the deployed, what kind of environment, orchestration things. You are going to talk about the Docker, you are going to talk about the Kubernetes, and once this Docker Kubernetes you are going to deploy on which environment, which cloud you are going to talk about, maybe AWS, maybe Google, and what kind of a cloud analogies you are going to the follow. So these complete holistic overview come under system design, not only architecture, not only microservice module, not only interaction, not only data management, not only CI/CD pipeline, not only Docker and Kubernetes, not only clouds, Amazon, AWS, whatever you talk. So complete overview as a system designs. While system design, we have to think how our application can be deployed, what kind of clouds we are going to think, cloud on the cloud, what kind of orchestration we are selecting, Docker, Kubernetes. Similarly, what kind of CI/CD pipeline we are going to build, how application frequently code is going to deploy on the Docker, and how application builds. So once you look everything, then you can say, hey, you are going to think right direction to design the system. System design is not the one point of view. System designing is the process where multi point of view we have to consider. Architectural point of view, modular point of view, interaction point of view, data point of view, CI/CD point of view, orchestration point of view, and deployment point of view. If you consider each and everything, then you can say, hey, our system design going on the right directions. Okay, hope this is very high level informations help you to understand the very basic about the system design. Okay, thank you for watching this.